This is one of my favorite things in algebra. I really like factoring, and that's what this whole section was about. This is the same sheet I've used for years and years and years. In this book, it's 3.3. 3.3, factoring polynomials, homework assignment. The first three are kind of weird in that they're just factoring examples. And your patterns for the whole worksheet are over here, by the way. So I'm just going to do one of them. And all you do is you plug into this thing. Don't do anything more. Just plug into it. It's about setting up. So this is a difference of two cubes. We have a cube, we have a cube. It's the difference of two cubes. And we could use this little pattern right here. It says a cubed minus b cubed is. So you have to figure out a. A is going to be the cubic root of 12 cubed, which is 12. And b is going to be the cubic root of 8 cubed, which is 8. So everywhere I see an A, I'm a 12. Everywhere I see a B, I'm an 8. By the way, let me write that. That's A minus B, A squared, plus AB, plus B squared. I just plug into it. I don't want you to do anything more than set up the pattern. That's how hard that problem is. That's how hard 1 and 3 are. You find out what A and B are, you plug into them. All right, some of the factoring one. Let's do 6. I'm going to pull an 8 from both pieces. That's going to make it 8w cubed minus 1. That's 0. And I know that this is a cube, and I know that this is a cube. A is the cubic root of 8w cubed, which is 2w, because 2 times 2 times 2 is 8, and w times w times w is w cubed. B is the cubic root of not negative 1, but just positive 1, which is 1, because 1 times 1 times 1 is 1. And I'm going to plug into the a cubed minus b cubed pattern above. That is an a cubed minus b cubed pattern. And it factors as a minus b times a squared plus ab plus b squared. Now we are solving, by the way. It says factor and solve. So after I factored, I've got to solve. I'm spending extra time writing this. You don't have to write this out, but you are supposed to know where it came from. There's an 8 out front that I pulled. A was 2w. B was 1, and it's a minus b. If I take a 2w and I square it, I get 4w squared plus 2w times 1 is 2w plus 1 squared, which is 1. And there's your pattern. And it is equal to 0, so now I use a zero product property. 2w minus 1 is 0, so w is 1/2. Or 4w squared plus 2w plus 1 is 0. And this piece right here, your notes specifically say, it's in your notes. Your notes say the answers are not real. All I asked for was a real solution. That's it. All I asked for. Nothing more. Let's look at 11. What do those numbers have in common? They're both divisible by 32. Oh, a little bit more. 32 and an x. If you pull a 32x from 32x to the fifth, you will have an x to the fourth left over because 32x times x to the fourth is 32x to the fifth. If you pull a 32x from 128, you'll have a minus 4. Now, when I look at this, I see a squared minus b squared. You are supposed to factor completely, like Tanner Oliver, he not going to factor completely. Bryce Rother, he not going to factor completely because they're not going to watch the video. But anyways, a squared minus b squared factors a minus b times a plus b. So this piece has some more factoring. A would be x, b would be 2. 32x times x minus 2 times x plus 2. Now I can use my zero product property. 32x is 0, which means that x is 0. Or x minus 2 is 0, which means x is 2. Or x plus 2 is 0, which means that x is negative 2. And I'm not explaining where that's coming from. I'm not explaining why that's a plus 2 becomes a negative 2, because I shouldn't have to. I guess I'll do 12. Maybe 10. Maybe 10 and 12. Anyways, for 12, 12 is definitely a factoring by grouping. If I just focus my attention on this pair and that pair, I'll probably see it. This is z to the fifth minus this 3z to the fourth. I can pull a z to the fourth from both pieces. And if I do that, I'll have z minus 3. Now I can pull from the second set a negative 16. And if I do that, I'll have z minus 3. Still equal to 0. It's the factoring by grouping technique. The common factor for both z to the fourth and negative 16 was z minus 3. But I'm not done. Z to the fourth minus 16 is a special pattern. It's a difference of two squares. It factors as z squared minus 4 times z squared plus 4. And we still have z minus 3. But wait, there's more. Z squared minus 2 is a special pattern. Factors as z minus 2 and z plus 2. Z squared plus 4, you actually know how this factors. Factors as minus 2i and z plus 2i. And then you have z minus 3. It's all equal to 0. I only want the real solutions. Notice I only want reals. It says that right up top. I only want the reals. So this guy tells me z is 2. This guy says z is negative 2 because I'm leaving the parentheses. These guys don't matter. They're not real. This guy says z is 3. 3 real answers, 2 fake answers, fifth degree polynomial. Makes sense. And number 10. What do all three of those things have in common? At least a 3 and an x. If I pull a 3x from 15x to the fifth, I should have 5x to the fourth. If I pull a 3 from 72, 24, pull an x, x squared. If I pull a 3 from 108, 36. So there's your first level of factoring. Now, what's it take to make a 5x to the fourth? Well, it takes a 5x squared and an x squared. What's it take to make a 36? A 6 and a 6. Does this work? Yes, because the outside can make 30 and the inside can make 6. And 30 minus 6, negative 30 plus 6 is negative 24. And you're really done factoring. This actually does factor. It's x plus root 6 and x minus root 6. A handful of kids will see that. A lot of kids won't. But anyways, I take each thing and I set it equal to 0. 3x is 0, so there's an x value of 0. Or 5x squared plus 6 is 0. And if you just do your two steps, you'll realize real quick these are non-real. All right, not real. Or x squared minus 6 is 0. Most people do this by adding 6 to both sides, and you take the square root. And you like baby pandas, so plus or minus root 6, just like you would have gotten by factoring. But nobody that I know of teaches factoring with radicals, at least not in high school. But it is doable. And that's where I'm going to pause this video, take myself a small break, and I'll be right back. All right. I'm going to leave the word problem for y'all. I really hope my second period class is doing this stuff. Please, second period, please, 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 please start doing your work. Please. This is a 4-term thing. Again, you just kind of focus on the first pair and the second pair. I notice that both of these have a c squared in them, so I'm going to pull it. It's the first commandment of math. If you can pull it, you pull it. If you pull a c squared from 7ac squared, there's got to be a 7a left. There's a plus sign, so there better be a plus sign. If you pull a c squared from bc squared, there's got to be a b. And the next set has a negative. Always pull a negative. At least 99 in 100 times you pull a negative. They both contain d squared. And if you pull a negative d squared from negative 7ad squared, you get a positive 7a, because if you pull a negative from a negative, it's positive. Again, I pulled the negative. I pull a negative from a negative, it's positive. And if I pull the d squared out, it's b. So we get c squared minus d squared times the common factor, 7a plus b. And then we hit this. I should notice this is a squared minus b squared with different letters. That's all it is, different letters. Factors is c minus d, c plus d, and then 7a plus b. Complete factorization of that polynomial. Anything on the back I want to do? I have not done hardly any of this with y'all. It's not really in your standards, which is why I hadn't been pushing it with y'all. This sheet came from last year's group. Actually, not last year's group, the group before last year, when it was a bigger deal. But you're supposed to solve this thing algebraically. It's an inequality, which automatically means 90 and 100 people just don't do it. But high expectations. So we're going to shift everything left. We're going to factor. Probably a 5 and a 1. Outside makes 15, inside makes 1. Minus 15 plus 1 is negative 14. And for the time being, I'm going to drop the equal. I'm going to drop the inequality. I'm just going to make it equal. And I'm going to use the zero product property. So x is negative 1/3 or x is 5. And these are actually not x values. They're called critical x values. Because these are inequalities. If we look at a graph, I'll try and make some more sense of it, but these are not the x values. Inequalities are answered with inequalities. They are not answered with equal to. They have an infinite number of answers. Now what you have to do, and this is the classical way of doing it, is you plot these things on a number line. I have equalities, so they're going to be solid dots. 1, 2, 3, 4, 5 is a solution, or at least part of a solution. And negative 1/3 is also part of my solution. And I'm going to test left between right. So something left of negative 1/3 is going to be a negative 1. I'm just going to plug a negative 1 in. I'm going to go back to the original equation. 3 times a negative 1 squared, supposed to be greater than or equal to 14 times a negative 1 plus 5. That's going to give me 3 greater than or equal to negative 9. And that is true. It's always true. I get to keep the left-hand side of this thing. This is all good. I know that it's true that x is less than or equal to negative 1/3. That is true. I'm going to test between negative 1/3 and 5. And I'm going to do that by plugging in a 0. Because that's easy. 3 times a 0 squared should be greater than or equal to 14 times a 0 plus a 5. That's false. That's 0 greater than or equal to 5. That's false. So I reject every bit of that. Now, since the left tail was true, the middle wasn't, the right tail probably is. I don't know that I've ever seen an example where that wasn't the situation. But I'm going to test something bigger than 5. I'm going to test a 6 because I'm testing right of 5. So 3 times 6 squared is supposed to be greater than or equal to 14 times 6 plus 5. That should be true. 6 squared is 36. 3 36s makes 108. 6 14s makes 84. Add 5, 89. True all day long. So I also know that x is greater than or equal to 5. That's one way of answering this, but this is the solution set. I like interval notation. I would love to see you write negative infinity to negative 1/3 with a bracket, union with 5 to infinity, bracket on the 5. And let's see here. You're supposed to learn this notation in Algebra 1, but you probably didn't. Or if you did, it's been 2 years and you forgot it. You're supposed to rewrite the cubic root of x squared using the form x to the p over r. This form is x to the power over the root. That's all it is. Here's the root. Here's the power. The root is the subscript of the radical, or the superscript on the radical. The power is the superscript on the variable. So once I've picked them out, I'm just going to rewrite this as x to the 2/3. That's all I got to do. That's it. And hopefully that helps you figure out 20. But you be very careful about 20. Very, very careful about 20. Anyways, that's it for the 3-3 work. I did 1, 2, 3, 4, 5, 6, 7, 8. I did 8 of 20 problems, which reduces down to what? 2/5. I did 40% of your homework for you. You're very welcome. Although for some of y'all, you'll be like, well, that's just not enough, Milbrath. I deserve a grade because I came to school. You don't deserve anything. You earn things. You don't deserve things.